for 6, we are still doing transformations of exponential functions. So the other lesson we did was the parent function. So now we know what the exponential function, it looks like this. It's either this one or this one, right? So it's the same sort of shape. One of them is a horizontal reflection. So we know this is the parent function. So now we've got the parent function in our heads. Now we can do transformation. So in general, we know that the exponential function has a horizontal asymptote over here. It's at y equals 0, right? The horizontal asymptote is there. And it goes through 1, right? We found that all of them went through 1, and it did this nice little whoosh really quick. Make that one go quick, and this one head down there. So that's what the exponential function looks like. The y-intercept was always 1, and we have the x-axis is the horizontal asymptote, which is y equals 0. So that's what we discovered yesterday or last lesson when we were talking about the parent function being an exponential function. And yes, we know the other one could be a horizontal reflection, but that's the basic shape. Okay, so we know that. Now, this is the general equation for an exponential function. We said the x had to be in the exponent, right? That's what made it an exponential. And we have the base here. Okay, so that is, the base is here. I usually call that, I think we call that the base. Yeah, usually call that the base. So I'm going to say, I'll refer to this one as the base of the parent function. Okay, so that b will be the parent function base, and then we'll have to the x. Now, everything around it is going to work exactly the way it did with all of our other transformations. So if this is my parent function sitting here in the middle, right, anything multiplied in front of it is going to be, let me try it. Okay, anything multiplied in front will be vertical. Remember, so we said vertical around it, and the last number here tacked on at the end was also vertical. Right? Does this remind you of when we were doing like the square root function? A number in front was vertical, right? And the number after was also vertical. Anything inside of it was horizontal. We're doing exactly the same transformations as chapter 1. So here and here. So this could be a vertical stretch or compression, right? And then the number tacked on at the end was vertical, but that was going to be my translation up or down, right? So if it's plus a number, it's up, and if it's minus, it's down. So those two numbers there. Now, the part that's going to be different is the horizontal. So when we were doing, say, the square root function, everything inside was horizontal, right? Everything in here was horizontal. Now, for this one, the horizontal is this part. So this part is my horizontal. That's new. That looks different, right? So it's not in the square root. So remember in the square root was like this. For the absolute value, the vertical was out here, vertical, vertical, and then inside here was the horizontal, right? For the absolute, those ones. For an exponential, the two on the outside look normal. That's vertical. But our horizontal will be up with the x. Up with the x. So everything up here is horizontal. So everything up here is horizontal. Then the rest of it's the same thing as what we did before. So this k here, this number here, that would be a horizontal stretch or compression. And it's going to be the opposite. So if it's 2, it'll be 1 over 2. Right? Does that make sense? So it's always going to be reciprocal. So I'm going to say reciprocal. Right? So same, reciprocal. And then the number here after, right, this one here would still be horizontal, and that would be left or right, right? And remember, it's opposite. So same as we did before. So if it's minus 2, I'm shifting it right 2. Does that make sense? If it's plus 2, I'm shifting it left 2. Right, so same exact, so it's nice because it's not new rules. It's the same rules, it's just where you look. Okay, so then now let's talk. That part's good. Okay, so look here. So tell me the parent function. So the parent function would be y equals 3 to the x. Does that make sense? So we're taking the 3, so you can highlight it, it's 3 with the x. That's my parent function. Okay, going to move this up a little. So that's how we get my parent function. What about for this one? What's my parent function for this one? Y equals, what's the base? 2, yes, 2 to the x. So then when I know it's the 2, that's not a stretch by 2, right? So that's not a stretch. That's my first initial function, parent function.
And so is 3 the
3's the stretch, yes. So 3's the stretch, 2 is the base. Here, no stretch. 3 is the base. So grab the parent function, and that's not the stretch, yes.
Well, like, when there's the number in front and the number in the back, will the middle number, like the base, will it be in the brackets with the?
Yeah, usually it'll be in a bracket, right? Because you have to separate it somehow. So look, so the number in front, the base is 1/3, but the number in front is the 2, it's the stretch, exactly. Right, so it'll look pushed out in front. I guess they could use a times symbol, but we don't tend to like those, right? Because it looks like X. Yeah. Okay, yeah, so it's in front. So that's why carefully grab your parent. So over here, what's my parent? Yeah, the 1/3 X. Does that make sense? Right, so you grab this base with the X. That's your parent function. And then here, what's my parent? 4, yes, the 4, and then to the x. So you're grabbing the 4. That's not a stretch. That's not a vertical stretch. That's that.
There needs to be a base, right?
Okay, there needs to be a base. There always has to be a base. Okay. We good? And what else do we have? So we got the parent. Okay, so now let's describe all the transformations, right? So we're going to do the same thing as what we did in chapter 1. Let's describe them all. And then in the next one is describe and graph. Not describe, but graph it only. And we do the equation. But I like to do the description first so we know what it means. And then we'll do the equations. We good? So here. Nothing in front, right? Nothing in front, so no vertical there. But there's a number after it, okay? So that's a vertical after. So we always go, and I usually go left to right, right? So that we always do the addition and subtraction at the end. So I usually start, that's the base. I have a negative there, so that would be a horizontal. That's horizontal reflection. Right, because of the negative, does that make sense? It's negative, so it's up there in the horizontal. So that means it's this reflection, left to right. Okay, horizontal reflection, and we can say in the y-axis, right? It's flipped over the y-axis. How about the 2? That's also going to be horizontal. Oh, should I number them? Do you need me to number them this time, or are we okay? We're better? Yes, okay, I'm going to just do 1. So that's 1. You don't have to number it on your answer, but I'll number it for just our first one. So 2 is the 2. So number 2 is the 2 there. Horizontal, and is that going to be a stretch or compression? It's a 2 there, remember? Horizontal's always, yes, so compression by a factor 1/2, right? So the horizontal's always the opposite. We got to get that in our heads. And then our next one is, that's done, that the x is just part of it, and then 1 here. So this 1 here, that's my third one. So 3. My third one there is a vertical, and that's going to be a shift which way? Up or down? Up. Up 1, exactly, up 1. Okay? All right, let's describe the next one. So we're just describing, and then in the next question, we'll graph it. Okay, I want to do the descriptions first, and then we'll graph it in a second. All right, so this one here. In front. So we're going to do vertical 1 here. So we've got 1, 2. 2 things happening there. So 1 is going to be my vertical. So I'm going to just list it in the order I'm doing it. So vertical, and it's a reflection in the x-axis. Okay, that's the negative. Number 2 is going to be a vertical. You can use the tick marks if you want. Vertical. And is that going to be a stretch or compression? Stretch. By a factor of?
3.
Yeah, factor of 3, so times 3. Then we have the plus 4, and it's up in the little exponent, so that means it's horizontal. So that's the third one. Yeah, so it's horizontal. And yes, it's a minus 4, right? Opposite. So it's going to be shift which way? Shift left 4. Does that make sense? We're always doing opposite.
Should we say shift or translation?
Translation or shift, yes. So translation or shift, yeah. Yeah, same thing here. So translation. There you go. All right. Last one, back over here. So I'll do this one in green. So this is going to be 4. So my fourth one there, I'm just doing different colors so you can kind of see. So vertical. Okay, translation. And it's going to be which way?
Down.
Yes, down 1. We're good? All right, so if we can do this, then the next question will be graphing it. But once you do this, you can do the equation. Good. Again, we know the parent function, so we're okay for that part. Okay, looking again. So we're going to start with 1. There's nothing here, because that's all part of the base. And then 2. So I only have 2 things happening here. The first one, vertical or horizontal?
Vertical.
Yes, vertical. Stretch by a factor of 2. That's it. And then the last one, vertical, because it's after, and that's going to be translation. Which way? Up 4. Easy, right? So you seeing it a little bit better now? Right? Once you kind of picture it, you can go, okay, I can see it like the square root and those other functions. Okay, how many things happening in this one? You've got, that's the base, so I'm going to get 1,
3.
yeah, 2, wait, 2, yeah, 3. 3, does that make sense? The negative, so that's going to be a horizontal reflection in, and if it's horizontal, it's going left and right, so it's over the y-axis, so it's y-axis. It's also a horizontal. The 2 is a
Compression.
compression. Wait, there's something about this question. What did he have to remember to do? That's it. Common factors. So do you remember when we did these? See how there's something attached to it. This, there was nothing attached. This, there was no number after there. Remember when we had, so say if I had a square root of negative 2x minus 4. You always had to factor. Does that make sense? You always had to unattach that from the 4. I still need you to do that for this one. How come I didn't need to do it from here? Because there's nothing attached to the x. Here there was a negative 2, but no number after. So this one I need to factor. Okay, so I'm going to factor this one. And this is going to be y equals 4, negative 2, x plus 2 plus 3. Okay, I'm just going to separate this. It's getting busy. So I need you to factor this part, just like we did here in square roots and absolute values and everything else. You had to factor out this one from touching this 4. So then this still is okay, but number 3 is going to be affected. So, oh, sorry, number 2. Number 2 will be affected. Number 3 is okay. So number 3 is this one. Number 2 will be affected there. So don't use this one. Oh, no, sorry, I was wrong. 1, 2, 3, 4 things happening. That's why I missed that. So 2 is good. 2 is good. 1, 2. And then I had the plus, what was my number there? minus 4. So this one here needs to be factored out. So that would be 3, and then this one has to be 4. So there's 4 things happening here. 1, 2, 3, 4. I'm going to rewrite that. Okay, so I'm going to rewrite it. So y equals 4, negative 2, x plus 2 plus 3. Okay, one more time. How many do we have happening? 1, 2, what's the one I missed? 3 factored, and then 4. Does that make sense? I missed that one here. And you have to factor it. So you should look and go, wait, that looks weird that this is so long and attached. I need to factor it. So we're going to keep this one here. Okay, so I'll put that there. I'll attach it there. That's for that question. So we want it factored. So 1, 2, 3, and 4. Does that make sense? Okay, so that's the tricky part. We love to give this question. We do, because we want to see if you can remember to factor it. And we asked you, I think, on every evaluation in Chapter 1. There was one that had to be factored out. So a number had to be factored. So when it's attached like this, right, when you have 2 terms, think of it like a binomial there in the horizontal transformation, and you have to do something with this translation. Okay, so note 1 and 2 are good. 1, 2, so we're going to still horizontal, and it's still going to be a compression by a factor of 1/2. Does that make sense? So that one still is 1/2. 3 was the tricky one, so I want it to be a horizontal, and we're going to say translation. So if you do the translation and you move it 4 to the right, I know right away you just didn't factor it out. Okay, so it's not going to ruin your graph. It's going to be shifted on the wrong way. So I need to factor that out, and I want to say it's going to be left 2, not right 4. Okay, so that was the tricky one there, 3. And my 4th one is this one here. That's a vertical, and that's going to be vertical translation, and that'll be up 3. Does that make sense? So we've got 1. This is 1, 2, 3, 4. All right? So once you have that, then now we can do the graphing, because now we can get our equation. Any questions with this one? Okay, so we're going to look for the factoring though, right? Look for the factoring. Look for when there's 2 terms there, that you have to factor out something from the first term if there's a coefficient other than 1.